Good morning, extended school year students. Today for writing, we are going to talk about something called a CER, which is Claim, Evidence, and Reasoning. This is a very specific type of writing. You're going to do it in science a lot. It becomes really important once you get to 7th and 8th grade, and then in high school as well. So it's kind of something that we want to spend some time on so we can understand it and we know what we need to do. I do want to start out by saying that a CER, Claim, Evidence, Reasoning, you're going to see it written as a CER, and your teachers are going to ask you to write a CER when they are talking about this. This is different from an argumentative essay. So if you were going to write an argumentative essay, you might write something like Xbox versus PS4. And although you might include facts about each system in your essay to say why you think one is better than the other, at the end of the day, it's really your opinion, and that would be based on your personal preferences. So a CER is not based on personal preferences or opinions. It is based on data, and that's where that evidence piece comes in. So let's talk about what each part of this type of writing means. To begin with, you're going to have some kind of science or experiment, or your teacher might give you a list of evidence and say, figure out what happened here. And you're going to have to make a claim about it. So a claim is, what do you conclude based on the information you are given? To go over it, a one-sentence answer to the question you investigated. So that's what your claim is going to be. Your claim is going to answer the question, and you're going to be answering it based on your evidence. It answers, what can you conclude? It should not start with yes or no. And it should describe the relationship between dependent and independent variables. You will definitely learn more about the differences between dependent and independent variables during your science classes coming up. But just so you know, an independent, I'm just going to abbreviate here, is the thing that is changed, or the variable, because we're being sciencey right now, that is changed. So for example, if you were doing a project and you wanted to see if plants grew faster while they listened to different kinds of music, in that example, you'd be changing the types of music you're playing the plant. Therefore, that would be your independent variable. And your dependent variable is basically the data you collected. What is being tested? So in that same example about the plants, you'd be measuring plant growth. So that would be your dependent variable. This can be tricky. I don't expect you to know the difference between these two right off the bat. It's something you will get used to as you go through science classes. So remember, your claim is going to be based on evidence. And evidence really comes down to this keyword of data. So if you did an experiment and you collected information, you're going to then use that data information to support your claim. You're going to leave out information that doesn't support the claim. And it can be both qualitative and quantitative. So let's talk about the difference between those two. Quantitative data has to do with numbers. It's going to be inches grown. It's going to be ages. It's going to be some kind of data that is linked to numbers. Now, qualitative data is more descriptive. It might be characteristics. It might be information from interviews, information you saw. It's more narrative. It's very different. Quantitative data is what we are going to be looking at for the most part when it comes to experiments. Reasoning. How does the evidence or the data then support the claim? This piece ties together the claim and the evidence. It shows how or why the data counts as evidence to support the claim, right? I can't say in my plant example from earlier, I'm not going to talk about the color of the plants. Hopefully they're green if their plant's growing, but say one of them looks more brown than the other, that's not going to be part of my data about growth. It's just not. I'm going to be measuring. There's no place to fit that in. And finally, with your reasoning, you provide an explanation of why the experiment results occurred. So you might have a closing sentence to tie it all together. Like, this makes sense because ... All right, let's look at an example. And this example doesn't give us any data to look at, but it still does help make sense of the process. So, in this fake problem, the problem is, which type of battery lasts the longest and maintains its voltage for the longest time? The name brand, which would be Duracell or Energizer, or the generic brand. Hypothesis. Now, a hypothesis, you've probably done these in science, but that's basically like an educated guess. And I would say, I'm not reading ahead. I'm not reading the hypothesis on this page yet. My educated guess about whether the name brand or the generic brand would last longer would be that the name brand would last longer. They're more expensive. They have a better reputation. That would be my hypothesis. And let's see. The hypothesis that they wrote here is, if a name brand battery Duracell is used in a flashlight, then it will stay lit longer than the generic brand because it has more stored energy. I completely agree. We have a little bit of different reasoning, but neither one of us are wrong. So here is how a claim with evidence and reasoning would be written about the batteries. They didn't give us a data table. I'm not sure if this data is real, if they just made it up, but this is how you would want your data to look, although you would actually have to collect it. So for the claim, the generic brand battery lasted longer and maintained its voltage for the longest time than the name brand battery. So this is interesting because their data must have showed that the generic brand was actually better than the name brand, which means our hypothesis is incorrect. Here's the evidence that they used. One flashlight with the name brand battery lasted for 6 hours and 39 minutes. One flashlight with a name brand battery lasted for 5 hours and 43 minutes. And the flashlight with a generic brand battery lasted for 8 hours and 16 minutes. So the generic battery lasted significantly longer than the ones that had name brands. Very interesting. Reasoning. Because the flashlight with the generic brand batteries stayed lit the longest, it proves that they will maintain the voltage for the longest time period. This proves that the name brand battery has more stored energy than the store brand. That is a sensible piece of reasoning. It makes sense that the generic brands have more stored energy because they lasted longer. They made the flashlight stay lit longer. So we may all be surprised, but that was the conclusion to this experiment. Now, here is your attempt. And this sheet will also be provided for you, so you don't have to worry about zooming in on this video. But let's go over what you're going to do here. Claim, evidence, reasoning, practice. Directions. Read the experiment details below, then use the observations to complete the CER conclusions. The problem. Does the size of the pot a plant is grown in affect how tall the plant will grow? So, what do you think about that? Is a plant with more space going to grow bigger than a plant with less space? I think maybe. They wrote their hypothesis here. If the plant pot is larger, then the plant will grow taller because the roots have more room to spread out. It's a great hypothesis. I would agree with that from the top of my head. But in order to write our CER and get the information about this, we have to look at the data. And this gave us excellent data right here. So diameter, this would be the size of the pot. And the bigger the centimeters, the wider the pot is. And then over here, we have plant height. And I don't know about you, but based on this data table, I would say that the bigger the diameter, the taller the plant. But I want you to look at the data table and decide on your own. And then you're going to write me a claim, evidence, and remember, you're going to get your evidence from here. You want numbers as your evidence. And then reasoning to support this. And in your reasoning, you might want to look back at the hypothesis, because I think it gave you a nice hint here. So in order to do this, you can simply send me an email and put C and what you wrote here, E and what you wrote here, and R and what you wrote here. You don't have to worry about making it too perfect. I just want to see what your thoughts are for each part of this. Let me know if you need any help. Good luck. I know this is a lot. I know I just talked for a really long time, and I am sorry about that. But this is important stuff, and I just want you to do well. All right, good luck, and I'm here for you if you need help. Have a great morning. Bye.